Here the Pythagoras relations. What Pythagoras says. The area of the square drawn on the hypotenuse of the right angle triangle is equal to sum of the area of the square drawn remaining two sides. So I am going to explain that. This is our right angle triangle. So look at this. This is our right angle triangle. Now they are telling this area drawn on the hypotenuse. Look at C squared. Area drawn on the hypotenuse, it is equal to squares, these two squares areas. If you add these two squares areas, you can get that one. So I will explain through the this one again. This is our right angle. This is our right angle. What is the drawn square on the hypotenuse? This one. Look at this. This is the square on the hypotenuse. These two square on the other two sides. If you get the area of this one, if it is 4, this is 16. If it is 3, this is 9. If it is 5, this is 25. You can check yourself. Then what they are telling, 9, 16, 25. If you add this 9 and 16, it's equal 25. You can check. If you add these two squares, it is 25. Again I am going to explain the Pythagoras theorem. Pythagoras say, if you draw a square on the hypotenuse, that square, that area of this square is equal to these two areas. If you add these two areas, it is equal. Look at this equation. So previous session also shows that this area, look at the huge one, then this two area, if you add, it's equal. This value can be filled with these two values. Look at this. If you go very first your program, you can see here very nice explanation here. Look at these two area, that's volume, they use volume, that's mean area also can be taken nicely. You can see here it can be fulfilled with these two volumes. Okay, now here next one. Now, so how do you find this area? So if length is AC, if you have a square, AC into AC, am I correct? Yes. Square of this one is AC into AC, AC square. What is the square of this one? AC, AB into AB, AB square. What is the square of this one? BC into BC, BC square. Easily we are using Pythagoras theorem for the right angle. Square of the hypotenuse equal square of other two sides. I think you remember very first time we learn about like this type of the equation. One side square equal sum of two numbers square. So this is the Pythagoras relation. All the time this your left side should be hypotenuse. You can't change these two. You have to put hypotenuse here. You have to put B and C other side. That's mean included side of the right angle. You have to take other side. I think next part I'm going to explain a problem. I think it is very easy. You have done. PQ is 8 centimeters, QR is 6 centimeters. Now you know the relations between this one, the square of the hypotenuse, writing PR squared, square of the, this is PQ squared, square of the QR squared is 6 squared. So you can apply PQ squared. Look at PQ, it's 8, you just put the 8 squared. QR squared, it's 6 squared. Then 64 plus 34, 36, it's 10. Then what do you supposed to do? Get the square root of either side for finding the PR. If you want to find the square root of 100, I think better to go with this table. So what's the square root of 100? It is 10. So if you remember that, very easily you can solve the problem. So now we can see the answer is 10 centimeters. So you can find this value. This Pythagoras relation is very applicable in the construction field. Okay, so you can find the application in here. Here the applications: A is a 5 meters long straight wooden rod in the vertical plane with the one end touch the top of the 4 meters height vertical wall, and the other end contact with the horizontal ground a certain distance away from the foot of the wall. Find the horizontal distance from the foot of the wall to the point where the rod is in contact with the ground. So shall we check that one? Here the sketch, rough sketch, they are telling 5-meter long straight wooden rod in the vertical plane. This is the what rod, 5, it should be meters, something wrong with in here, you put meters here, 5 meters rod you kept in here. So that from the bottom to top of the wall, the vertical it is 4 centimeters. So you want to find the distance, this point, this is the bottom of the wall, and this is the next end of your wooden rod. So how do you find this one? This is a right angle triangle. You can apply the Pythagoras relations for the right angle triangle. You can see here AC squared equal AB squared plus BC squared. Then AC is, what is AC is 5 squared, plus AB is 4 squared, plus BC squared. Then you can, I have done this type of the problem. You know your left side, you know your right side one value, so then you have to bring this value in other side. It comes 9, get the square root of the other side, you can get it is 3 meters. Okay, so sometimes these are very important part. Pythagoras relations can be come with the combined right angle triangle. So I am going to explain some combined right angle triangles. You can see here this yellow right angle triangle, so it is combined with another blue right angle triangle. So sometimes they will give these two values, so you have to pay attention with my cursor point, that laser point in red color. So these two lines given, so how do you come it? Okay, now okay, now these two side also given, this side you want to find, this side you want to find, this side also given. So how do you find this red color? First of all, you have to consider only yellow color right angle triangle. You can see two side, if you know, you can find this side. Yellow color right angle triangle, you can find this side. So blue and yellow margin you can find. Then after you know blue color right angle triangle, two side. Now you can find this red side. That's mean in the combinations, if you have a combinations of the right angle triangles, you have to use Pythagoras relations 2 times. When you are working with the problem, this session will be very important. Another combination you can see, I draw this one is very, I think you can see that color. There are two right angle triangle. Sometimes if you know the, look at this line, this hypotenuse, and if you know this hypotenuse, so if you know this height, or otherwise total height of this one, then you can apply the Pythagoras relations 2 times and you can find other side. First you have to find what is the common side. Here common side is this horizontal side. The what is the common side in this one is the vertical side. Thank you very much.